Millions of tons of sweet potatoes are harvested across the United States. They roll off the fields in endless streams, headed for grocery stores, food factories, and export markets. Sweet potatoes are one of America's most important root crops, valued for their nutrition, long storage life, and versatility. But here's the part very few people ever see. For every truckload of perfect sweet potatoes that reaches consumers, 15 to 30% of the crop is rejected. Too small, too large, bent, cracked, misshapen, bruised during harvest. Not broken, just not beautiful enough. That means hundreds of thousands of tons of sweet potatoes every single year never make it to supermarket shelves. Before we step inside this hidden network, don't forget to like, subscribe, and turn on the notification bell so you never miss our deep dive documentaries into the industries that turn waste into opportunity. The United States produces roughly 3 to 3.5 million tons of sweet potatoes each year, with major growing regions concentrated in North Carolina, Mississippi, California, Louisiana, and Arkansas. Sweet potatoes are harvested mechanically. Massive harvesters lift the roots from the soil, shake away dirt, and convey them into bins. Even with modern equipment, damage is unavoidable. Roots collide, skins scrape, shapes vary wildly. Once harvested, sweet potatoes are transported to curing and packing facilities. Here, the real sorting begins. Automated grading lines scan every root for size, shape, and surface defects. Optical systems measure length, curvature, and skin integrity. What doesn't meet strict retail standards is immediately diverted. In a large packing facility, thousands of tons of sweet potatoes can be rejected in a single week during peak season. If these roots were dumped into landfills, disposal costs would be enormous, and the environmental impact severe. Instead, they enter a parallel supply chain, one designed specifically for reuse. Rejected sweet potatoes are loaded into bulk containers and hauled to nearby processing yards. Speed matters. Sweet potatoes are high in moisture and starch. If left unmanaged, they rot quickly. Within hours, they must be crushed, dried, or digested. At feed processing plants, the transformation begins. Whole rejected sweet potatoes are washed to remove soil, then fed into industrial grinders. The roots are shredded into mash, which is either fed fresh to livestock or dried for longer storage. Drying systems reduce moisture content from over 70% down to less than 12%, creating a stable, energy-dense feed ingredient. Once dried, the material is ground into meal or pressed into pellets. These pellets are rich in carbohydrates and calories, making them ideal for cattle, hogs, and poultry. A single medium-sized feed plant can process 50,000 to 100,000 tons of sweet potato waste per year, replacing large amounts of corn and soy in animal diets. For farmers, this is a win on both sides. Sweet potato growers avoid disposal costs. Livestock producers gain access to affordable, locally sourced feed. Entire rural economies benefit from a waste stream turned into nutrition. But feed is only one destination. Another major pathway is bioenergy. Sweet potatoes are essentially stored solar energy, starch locked underground. In anaerobic digestion facilities, rejected roots and processing waste are fed into sealed tanks along with other organic residues. Inside, bacteria break the material down in the absence of oxygen, producing biogas rich in methane. Even though sweet potatoes are wet and heavy, their high starch content makes them excellent biogas feedstock. Large digesters can process hundreds of tons per day, generating renewable electricity and heat. That energy powers farms, food factories, and sometimes entire communities. What remains after digestion, the digestate, is not waste. It is a nutrient-rich soil amendment returned to fields, closing the agricultural loop. Nitrogen, potassium, and organic matter flow back into the soil that originally grew the crop. In some regions, sweet potato waste also feeds industrial starch extraction. Facilities separate starch from rejected roots, producing a fine powder used in food manufacturing, adhesives, paper coatings, and biodegradable packaging. Sweet potato starch behaves differently than cornstarch, offering unique viscosity and binding properties that certain industries prefer. Advanced processors push even further. Research-driven facilities extract polyphenols and antioxidants from sweet potato skins and flesh. These compounds are used in dietary supplements, functional foods, and cosmetic formulations. What once failed cosmetic standards for produce now meets cosmetic standards for skincare. Across all these pathways, logistics coordination is critical. Trucks move rejected crops daily during harvest season. Processing plants operate at peak capacity for just a few intense months. Storage, moisture control, and contamination prevention are tightly managed. A delay of even one day can turn valuable biomass into a liability. Economically, the impact is massive. The sweet potato recycling ecosystem saves growers millions of dollars annually in disposal costs. It reduces pressure on landfills. It displaces fossil fuels. It lowers feed costs. It creates jobs in rural processing plants that would otherwise not exist. Environmentally, the benefits are even greater. Diverting organic waste from landfills avoids methane emissions. Producing biogas offsets coal and natural gas. Returning nutrients to soil improves long-term fertility and water retention. Each ton of recycled sweet potato represents carbon kept in circulation instead of released into the atmosphere. And yet, almost no consumer ever thinks about this system. They see fries, they see mashed sweet potatoes, they see packaged food. They don't see the parallel industry running quietly beside the food supply chain, collecting what was rejected, reshaping it, and reinserting it into the economy. This is not charity. This is not waste management. This is industrial efficiency. The hidden sweet potato recycling industry proves a simple truth of modern agriculture. Perfection is optional, but value is not. Even crops that fail visual standards can power animals, fuel factories, and support entire regions when systems are designed to capture their potential. From misshapen roots pulled from the soil to pellets feeding livestock and gas-spinning turbines, rejected sweet potatoes travel a second life, one just as important as the first. If you enjoyed this journey into one of agriculture's most overlooked industrial systems, make sure to like, subscribe, and turn on the notification bell. We'll see you next time, inside another hidden industry where nothing truly goes to waste. Crisp, cool, and refreshing. Cucumbers are one of the most consumed vegetables in the world. From pickles to salads, sushi to skincare, their versatility is unmatched. But have you ever wondered what it takes to grow, harvest, and process the millions of tons of cucumbers that reach your grocery store every year? In this video, we'll take you behind the scenes of incredible cucumber farming, where high-tech agriculture meets age-old practices. From seed to supermarket shelf, from open fields to modern sorting lines, every step is a blend of precision, efficiency, and care. Let's discover how millions of cucumbers are planted, nurtured, hand-picked, washed, sorted, and packed, ready to travel across continents and onto your plate. Cucumber farming begins with one essential element: the seed. Cucumber seeds are carefully selected based on the variety and the purpose, whether for fresh market consumption or industrial pickling. In large commercial farms, planting is done in spring or early summer, depending on the region. The soil must be well-drained, nutrient-rich, and loose, perfect for the cucumber's shallow root system. Farmers often use raised beds covered with black plastic mulch. This not only retains moisture, but also controls weeds and increases soil temperature, speeding up germination. Seedlings are either sown directly into the field or pre-germinated in greenhouses. Spacing is crucial. Cucumbers need air circulation to prevent disease. Each plant is usually spaced 12 to 18 inches apart, with rows 3 to 4 feet wide. Drip irrigation systems run beneath the mulch to deliver water precisely to the roots, minimizing waste and promoting strong growth. Within 5 to 10 days, the seeds sprout. By the third week, the vines start spreading. By week 6, flowering begins, and within 2 weeks, tiny cucumbers appear, growing rapidly, thanks to optimal heat, sunlight, and regular feeding. There are 2 main cucumber growing systems: open field cultivation and greenhouse farming. In open fields, trellising is common. Farmers install support structures like bamboo poles or plastic netting to train the vines upward. This prevents fruit rot from ground contact and makes harvesting easier. In greenhouses, cucumber vines grow vertically with string trellises under controlled temperature, humidity, and lighting. This method allows year-round production, especially in cooler climates. Advanced hydroponic systems deliver nutrient-rich water directly to roots, accelerating growth and increasing yield per square meter. Integrated pest management is also key. Farmers use natural predators like ladybugs or introduce pheromone traps to reduce harmful insects without chemicals. Cucumbers are highly sensitive to water stress, pests, and powdery mildew. Daily monitoring, pruning, and irrigation adjustments are part of the routine. By 50 to 70 days after planting, the cucumbers reach commercial maturity, between 6 to 9 inches long, deep green, and firm. They're ready to harvest. Despite automation in many crops, cucumbers are still mostly harvested by hand, one by one. Farm workers move through rows with crates or baskets, gently twisting each cucumber from the vine. Timing is essential. Cucumbers grow quickly, and waiting even a day too long can result in oversized, bitter fruits. Harvest typically happens early in the morning to preserve freshness and minimize heat exposure. Workers wear gloves and use shade nets on collection carts to prevent sunburn on the tender skin. In some high-yield farms, semi-automated carts with conveyor belts allow workers to place cucumbers directly onto a moving belt that carries them to onboard bins. Initial grading happens in the field. Misshapen, overgrown, or damaged cucumbers are culled immediately. Only uniform, glossy green cucumbers are selected for the fresh market. Each crate is labeled with harvest time, field section, and picker ID, ensuring traceability and quality control from the very first touch point. Within hours, the cucumbers are transported in cooled trucks to nearby processing and packing facilities. At the processing plant, speed and temperature control are critical. Freshly harvested cucumbers arrive at the facility and are first emptied onto a water flume, a gentle washing channel that removes dust, debris, and soil while cushioning the fruit. Next comes a soft brush scrubber that gently cleans the skin without damaging the surface. High-pressure misting systems keep cucumbers cool and hydrated throughout the process. After washing, cucumbers pass through a hydro-cooling tunnel, a chilled water bath that quickly drops their temperature to preserve freshness and extend shelf life. This step is crucial. Cucumbers are over 95% water and highly perishable. Without rapid cooling, they begin to dehydrate and soften within hours. Once pre-cooled, they're air-dried and moved to the grading line. Here, automated cameras and sensors inspect each cucumber for size, length, curvature, and color. Rejected cucumbers are diverted for juicing, animal feed, or compost. Graded cucumbers are sorted into different categories: Class A for premium retail, Class B for food service, and Class C for processing. Packing depends on the customer. Supermarket cucumbers may be shrink-wrapped individually to reduce moisture loss. Others are packed in plastic trays or bulk boxes. Some farms use eco-friendly alternatives like compostable wraps or reusable crates. Before packing, cucumbers are misted again to rehydrate and given a final inspection by human sorters to catch any defects missed by machines. Each box receives a label indicating origin, harvest date, variety, grade, and tracking barcode. For export shipments, phytosanitary certificates and temperature loggers are included. Packaging is done in temperature-controlled rooms to maintain freshness. Once boxed, cucumbers are stacked onto pallets and stored in cold rooms at 10 to 13 degrees Celsius with 90 to 95% humidity. For long-distance transport, reefer trucks and containers ensure a continuous cold chain from farm to store. While slicing cucumbers dominate fresh markets, pickling cucumbers follow a slightly different route. These are smaller, crunchier varieties harvested at just 2 to 4 inches in length. After sorting and cooling, they're sent directly to pickling facilities, where they're immersed in brine tanks or vinegar solutions. Pickling operations involve stainless steel vats, automated filling machines, and airtight jar sealers. Spices like dill, garlic, and mustard seeds are added in precise proportions, depending on the recipe. Pasteurization is used to sterilize the jars and extend shelf life. Pickled cucumbers are a global favorite, from American dill pickles to Korean oisobagi and German gherkins. After processing, jars are labeled, boxed, and palletized, ready for supermarket shelves worldwide. Modern cucumber farming is evolving toward sustainability. Water-efficient drip irrigation, biodegradable mulches, and biological pest control help reduce environmental impact. Precision farming tools like GPS-guided tractors and AI-based crop monitoring ensure better yields with fewer resources. Some farms are experimenting with robotic harvesters that can gently pick cucumbers using soft grippers and machine vision, promising solutions to labor shortages. Vertical farms in urban areas are also producing cucumbers hydroponically, reducing transport miles and using 90% less water than traditional farms. Researchers are developing new cucumber varieties with improved disease resistance, longer shelf life, and better taste, ensuring this humble vegetable continues to thrive in future markets. From sunlit fields to glass jars, from hand-picking to high-speed sorters, the journey of the cucumber is one of quiet complexity. Behind every crispy slice lies a hidden world of science, labor, and logistics, ensuring that millions of tons of cucumbers are safely and efficiently harvested, processed, and delivered around the world. Whether it ends up in your salad bowl, sandwich, or pickle jar, the next time you bite into a cucumber, you'll know just how much goes into every crunch. Thanks for watching. Beneath the glossy skin of this deep purple fruit lies a fascinating story of soil, science, sun, and centuries of tradition. From tiny seeds to vibrant harvests, eggplants, also known as aubergines, are more than just a culinary favorite. They're a testament to modern agriculture and ancient farming wisdom.
カモナスです。カモ eggplant. They are getting bigger and bigger.
Today, we journey across lush fields and advanced greenhouses to discover how millions of eggplants are grown, nurtured, and harvested across the world, ready to be turned into everything. This is amazing eggplant agriculture. Every eggplant starts with a seed, but not just any seed, carefully selected, scientifically treated, and genetically optimized for productivity, resilience, and flavor. Most commercial growers start with hybrid seeds, chosen for traits like disease resistance and faster maturity. These seeds are often pelletized to make mechanical sowing easier. Seedlings are typically started in nurseries, often indoors or in controlled environments. Here, trays of potting mix or cocoa peat are moistened and seeds are gently pressed in, then covered with thin layers of substrate. Within 5 to 10 days, tiny green shoots emerge. These seedlings are then allowed to grow under carefully monitored conditions, constant temperature around 25 to 30 degrees Celsius. filtered sunlight, and daily watering through mist or drip systems. Once they reach a height of 10 to 15 centimeters with 3 to 4 true leaves, they're ready to be transplanted.